You know, actually, what these, this would be 4x, right?
Yeah.
We divide by 4?
Yeah,
No.
2.
We divide by 2 or 4?
2. No.
No, the answer is 2.
The answer is
You
2.
divide by the coefficient, that's what the variable.
Okay.
There we go. And then coefficient. The number. Yes.
Half.
You have enough to do it?
What number are we doing?
You have enough to do it?
4x.
How many more do you need?
4 x's.
Well, how many
Okay,
more?
plus, no, how many more do you need?
4x. It was 9.
I don't have enough.
2 more? And there,
Wait, do you have plus on yours?
is that, do you have enough there? You need 2 more.
You guys can
Oh,
work
there
together.
it is, okay.
So we subtract 5. Okay, what do we get in? What do we do now?
You 2
Now
okay?
what do you have left?
That's
4x
forward.
equals
I need to record.
7.
So you have it, and then you divide it up, and you got
Divide by 4.
2?
Divide by 4.
Is that what it is?
Yeah.
Yeah, you divide it by 2. You can model it with that. You got it? You have it? X is 2? Or whatever the variable is that you want to call it.
Drawing here. I've never been good at drawing paper.
That's why.
So you have it all, you guys divide it up? So you have, this is 13? You need more? This is 12 plus 5. So first thing we're going to do is, you can't break this up.
Subtract 5 in here, right?
The first thing you can do
I
that.
got it the first time. X equals 2.
So then you break it up into 4 equals
Wait, man, I just got really drunk. I just got really drunk.
Bingo. You got it.
Yeah.
And then you're left with,
This,
right,
that was the big one.
so now we're turning into a game. We have to stakes a little. Yes,
Yes!
yeah, hurry back, listen real well down the hallway. Okay, so, before you guys end up getting too lost in this, I see that we've all been able to manipulate the algebra tiles, yes. Now if we can take that and transfer it into writing the equations, that's something that we'd like to see. Because ultimately on paper is where all this needs to get done. So in your notes, would you at least take this one right here, 4x plus 5 is equal to 13, and follow along? Now, I heard some of you right away at the beginning, you just looked at it and in your head you mentally you threw it together and you said, well, it's got to be 2.
Yeah.
And that's great. And you know, but we want to be able to use the steps like this to be able to separate and isolate that variable, because not always will they be simple integer values. And not always will we even know all of the numbers that are involved. The whole thing might be written as variables. So we're preparing for more and more unknowns. So if I was going to write this problem out, and I was going to solve for x, what we're doing here is we're doing inverse operations. So the first thing you did is subtracted 5 from both sides, so we want to show that on paper. And then, when you have 4x plus 5 minus 5, that's going to be 4x. And 13 minus 5 is going to be 8. And then we're going to show the division by 4, and come up with x being equal to 2. So in your homework, this is what I expect to see.
Well, he was saying like in a lot of the questions to use like the graph to.
Yeah,
Well,
so
in some problems, yeah, in some problems, see, a graph is one way to solve it. So in this case right here, if you were to graph 4x plus 5, you're gonna end up with a pretty steep graph that crosses at 5, it's gonna look like this. And then y would be equal to 13, so you're gonna have a horizontal line here where y is equal to 13. In this point right here, you can find that answer from a graph, yes. That's one way to find the solution. A second way is from an equation.
Equation makes more sense.
Well, but they're different tools and they have different purposes in different situations. And right now, I'm just teaching you tools. This is one tool which we went through in previous lessons. This is the tool that comes from this lesson. We'll also look at making tables of values. And that's a tool that we use the graphing calculator from a great deal. But we're not there yet. We'll do more of that next year. But they each have their own value. Willa, question?
How can you tell that the graph for that will look like that? The graph for 4x plus 5.
Yeah, so this is y equals 4x plus 5. How can I tell? Well, that 5, we discussed a little bit yesterday, that's where it crosses the y-axis.
Yeah.
And then 4 is how steep it is. When this number was positive, remember things were going up, increasing. And when we had a negative 3 yesterday or something like that, it was decreasing, it was going down. We will spend more time with that, okay? Don't worry about it. We will spend specific time discussing how that equation gets put onto that graph without making a table. Okay, so this right here, this is how I want your work to be looking. Now, in some situations, we will have problems that might be something like this, where we have a third of x is equal to 12, for example.
Do the reciprocal.
So yeah, in this case here, we're going to multiply by the reciprocal on each side. So then you'll have x is going to be equal to 36. But in this lesson that we're going into, we're going to throw a twist in this. So for example, if we had something like 2/3 of x plus 4 is equal to, oh gosh, 37. So mechanically what we have to do is we think to ourselves, what am I writing on the right-hand side here?
Order of operations.
It's order of operations, isn't it? Except we're not using the order of operations because we've got this variable in the middle of the equation. We can't multiply first. We can't then add. So what we're doing is we're unlocking what x is. So we are undoing the order of operations. We go backwards. Come here, look at
They subtract.
it. There's no need for a calculator. So you look and you say, is there addition or subtraction?
Yes.
And then undo it. So to undo adding 4, you would subtract. And you do to the left and to the right the same. Again, some people like putting a line down like that. That's cool. Then 2/3 of x plus 4 minus 4, those cancel. That makes a 0. They call that zero canceling in some textbooks. So you're left with 2/3 of x, and we have to write that down. We're not doing this one in our head. I mean, some of you can, but I want to see the work. Phoenix?
Why is it not divide by 4 instead of?
Because it's addition.
Because if you divide it by 4, this would be +1 when you're done, and then you'd have 2/3 divided by 4, which is 8/3, and then it would just turn it into a more complex mess. So we have to remove those 4 before we can undo this multiplication. Otherwise, you have to undo the multiplication to everything on the same side of the equal sign. Ariel?
Did you write that addition, like add 4? Or is it multiplied by 4, like in the first row? Like the very first equation?
This is 2/3 times x plus 4
Oh, okay.
equals 37. Okay, so let's go back to what we were doing. We subtracted 4 from both sides, so 37 subtract 4 equals 33. Okay, now, yeah, Clover? I'm sorry, you got such a quality mask on, I can't hear through that.
You times the fraction by its reciprocal?
Yes, you do. We're not gonna divide by 2/3, we're gonna multiply by the reciprocal. And then all of that cancels out to make 1 times x. But then the same thing has to happen over here. Yeah, so you're gonna get some exercise on your multiplication and division of fractions and decimal numbers. So we treat this as a fraction, straight across the top, straight across the bottom. What's 33 times 3?
60,
99, and then 1 times 2 is 2.
Nice.
So with a problem like this, you're welcome to leave it as 99 halves. Or, what would it be as a mixed number?
49.
49 and a half. Because 100 over 2 would be 50. And we're a half short. We're not done yet, but, yeah, Willem.
So would it not work if at the beginning you would have, if you had multiplied by the reciprocal before subtracting 4 and then x?
All right.
And then
So if you wanted to do, what did you want to do first? If you would do what?
if you had multiplied 2/3 by 3 over 2 first, would that work?
Okay, so if you multiply it by 3 over 2, then you have to multiply this whole side of the equal sign by 3 over 2. And then this times this is x, and then that ends up being 12 over 2, which is 6. And this ends up being, oh my gosh, what is it, 90, 111 over 2. So you have x plus 6 equals, you want to do that. We do not want you to go that way. There's a reason we started with the algebra tiles, because you could see just pulling away those pieces, and then having the x's and such right in front of you. So, where in the world did we put it out here? We just flat out need to practice
This is
this.
the first time they learned that a new term, like the plus or
Two-step?
minus? Yeah.
Is this the first time that you guys have done 2 steps? Yeah, it is. Because we might have done it last year in COVID school, actually. But I mean, I can count on one hand how many people I saw in COVID school. COVID school was a big loss.
Yeah.
Oh, I remember.
This helps me understand the ninth graders I have now, because I assume they had already done this a bunch.
Well, yeah, they did. They
okay.
got it earlier. Not a lot of people often.
This does not go away. More numbers, more variables.
I'm not quite sure.
So, when it comes down to these types of equations, I think that the lesson title is what the first question, the first 2 questions is driving at. This lesson title, is it 9? I think it is. It's called Solving solving y equals ax plus b. That's the title of the lesson. So, if you think about all of these problems that we've done, we've always had a y, we've always had an x, except we said what the y was gonna be equal to. So for example, the 4x plus 5 equals 13, that was written like this. So this a is the coefficient. That's the coefficient of x, that's the multiplier of x. And then this value 5, that's the b value. And eventually it's going to stick a little bit more, but that's the number where the graph crosses the y-axis. It's called the y-intercept. So when you're asking how I scratched out that graph so fast, I just know from looking at this that that's the number where it crosses the y-axis. But for now, if we were going to identify in this problem here, 13 4x plus 5, we're going to say that the y is equal to 13. The a value is equal to 4 because that's what's being multiplied by x. And then the b value is going to be 5 because that's what's being either added or subtracted. You see, some of these problems are going to have subtraction, and they're going to have negative coefficients. They're not all going to be nice positive numbers to work with. So again, we're going to get lots of practice with our positive and negative multiplication and addition. Yes?
Wait, what is the coefficient? Is it just like
So the coefficient is this number here that's in front of a variable. So anytime you write like 2 times a, for example, if you wrote 2 times a, 2 is the coefficient of a. So that's a word we're going to just be using more and more. We'll use the word coefficient instead of using 3 words to describe that thing, the multiplier in front of x. So I want to throw one more out in front of you, okay? Maybe even 2. Let's say we had a problem like this. Negative 2x is equal to 12. So there's not a b value, it's just x and then its coefficient. So if we're going to write out how to solve this, what is the value that you're going to possibly divide by? Negative 2. So you have to remember that. Let's say you had another problem which was something like this. C subtract 12 is equal to 37. So in this case here, how do we undo subtraction? Again? Addition, yeah, so you're going to have to add. So when we have a problem that's going to be, for example, like number 13. Take a look at number 13. It's subtracting 44. Well, when you undo that, you're going to have to add. You have to use addition. And if you look at number 18, way down on the bottom right-hand corner, number 18, you see that coefficient is a negative 5/12. So when you multiply by the reciprocal, it's going to have to be a negative again, because a negative multiplied by a negative will give you a positive.
The same rules that apply for multiplying negatives apply for dividing.
Absolutely, same rules for multiplication and division of positive and negative values. So things are going to start getting a little bit more complicated with the numbers, yes. There's one more twist that's going to show up, because what they do is they call upon old skills and start adding them in. And one of those skills is going to be combining like terms. So for example, having a problem like this where 14 is equal to gosh, I don't wanna make, yeah, something like 2x plus 3x minus, I'm gonna say plus. Plus 4? Yeah, good, thanks. So if you have something like this here, you might think, well, I'm gonna subtract 4 right away, and you can, nothing wrong with that. But eventually, you're gonna have to add the x's together. And it's up to you when you wish to do it. Usually, what I like to encourage is that you add the like terms first. And then if you write that out, yes. Okay, let's back up. I see. Don't worry about number 3. I'm still, I probably shouldn't have handed you your sheet yet. No, I shouldn't have. Because you guys are all checked out, trying to do the homework.
But if you look at 12 and, that is combining like terms,
Yep. 16 has the distributive property.
yeah, they all have different things that you need to know from that.
I think we only got
Where to identify A and B?
Did you read what it says up above? Read what it says up above. So this is the form, that's your equation. So using this model and that equation, what did they put in the place of A, what do they put in the place of B, what do they put in the place of C?
We use X and W.
X always is X with these. Because they aren't asking you what X is, they're just asking for A, B, and C.
You want him to start the homework, Mr. Baker, or you want to keep?
Are we doing the whole front?
Yeah. Yeah, negative 1 times 1 negative
So that'd be negative.
Yes. Do the negative, I'm not doing the negative, I'm fine. And then that gives you a line on to the 3. Nobody divided by a negative is a positive, yeah.
Mr. Diggins, would you like them to start on the homework, or do you want them
Yeah.
to focus on the?
Well,
Are we doing all of them?
I'm just gonna, I want you just to start on the homework. Yeah.
Can we do all of them?
Do you wanna do all of them?
No, of course not.
25.
You're right.
Okay, so what number are you on? You're on 4? You're on 6?
1.
You're on 2? Okay, 1, 2, 3, 4, 5, 6, 7, 8.
Do what?
And then it's gonna change, and I'll write the rest from 1 through 8.
Nice work.
And then 12, 13, I'll just write them. There. 13, 18, 19, 21, 23.
Yeah, and there's only like 18 of them.
your kids testing sixth period at all? Yeah, okay. Just cause I was gonna pull kids in, but if they're taking a test, I don't wanna distract them that much. You're welcome.
So I still have a citizen to them about checking their answers.
Even though it's on there,
What's that?
even though that's part of the direction.
You're right, yeah, I haven't said anything, nobody's asked about it yet.
Okay.
I wanna just get them going through some of the answers,
Okay.
and then go back.
What does it mean by identify the ABCs?
Lizella is a math helper for seventh period, so if you want her to split all of these up into the appropriate
It's the
things.
same,
With all of these, what?
The algebra files into like that.
This is what now.
Okay, I just mean if you need somebody to do math and stuff like that, she's available seventh.
Okay, thanks.
Yeah.
No, she's supposed to be over at homework, don't help me, that's what I thought.
She is, but she could do stuff like that too.
So, the ABC then? Yeah. Take a look here. That is the tab, so in this one, what did they put in place of A? What did they put in place of B? That's all, it was asking me.
So there's no C.
No, actually, that's wrong.
This one is C.
Yes.
Because if it's 8 times 3, that would be
This is double E plus E.
What?
Well, and plus.
They want to identify the
Oh,
students,
okay.
and it's, 8, and you.
No, but I mean like for A, they want to say what A.
A?
You can write it any way you want.
So you identify the A and the B and the C of the equation?
The other one.
Oh.
Yeah.
So what's A? And then you do
So basically, like, 8 would be A,
Just
and
eight.
then negative 2
So A is just the
would be
coefficient, and then
negative
that's
26
the
would be
variable. Exactly. And then with the. Comma, this is all for A, just the letter A. This is the letter A, so you're answering this question here, and you're answering this question here.
I don't know what the time is, is that right?
Yeah, no, it is negative.
It is negative?
Yeah.
Okay.
Yes.
Yeah.
Wait, yeah, it's just that.
So you have to get variables on one side, so you could decide if you wanna work with it. Oh, sorry, I thought the equal sign was between those two, it's not. So we combine like terms, so what I do is a coefficient with a variable is a like term. So I put shapes around them, so I would put a circle around that, and then I'd look to see if there's more, and then do a circle. And then a 7's on its own, so I do like a triangle. There's a positive, there's a positive in there. I like to put shapes around them, so I know they're the same. So you can combine this one with this one, because they're the same shape, right?
Wait, Mr.
And then you have whatever's left over. Does that make sense? I usually use colored pencils too, because then you can see it's different colors.
12 equals negative half Q plus 8, so then I minus the 8. And then I put my half on that, which that is
No one does.
8.
He just,
Then
his goal is to always go home without.
D equals
That's a goal.
11.
Negative half, so you should have multiplied by negative 2. And then negative 2 equals negative 8. You're correct.
So where did the negative?
So I just forgot to add the negative
I think it is. How would you find out?
I did it just say,
How would you know if you're correct or not?
oh yeah, do negative 8.
Put it back into the original equation. Yeah. How do you know how to
Where you're going with this. I would rewrite that equation, okay, that was big, so, that's what we just did. Oh, it is tough.
Last one was he was happy after like one of the people killed his friends in the battle.
Oh, yeah, no wonder, yeah, I forgot, cause you bent the metal and then the guy goes,
There
Sit it up there. You're right, you're right. Patient.
I wrote this one.
Honestly, but
It's the plus nine.
So what you're trying to do is take the coefficient of the variable by itself. So I'm on this one, on one side of the equal sign.
What this does is it puts it down.
So how are you gonna cut that out? You're adding
Get through the first one like that.
not yet. Are you worried about the inverse operation?
Get through number three.
How would you get rid of it?
Inverse operations. Or you wanna-
You have to do something to get rid of it, you can't just get rid of it, just round it off. I have two.
So go to town. But that's not it.
So I think that's the
Well, I think you might be.
And then you said you did it to this side.
That one. There's one. Here's one. Not that. I rewrite it and then do the right. What's that? Sure. It makes it easier to check them. Ooh, yeah, just set them, I'll straighten them out. I'm gonna do the plus ones in here, thanks. Does that have pluses on it?
Yep.
Sweet, thanks.
I missed it. I know I had to do the thing but before I go. Have you seen Falcon and the Winter Soldier?
Can't say, I have to fly to the other end of the building, though, I can't, if you wanna talk, we can talk after school. Okay.
What about it?